Guys, I just hit the record button. So
All right, thank you. I'll take over the screen then now. Let's see. Where's the, oh, right down here. Okay. Can everyone see that okay?
You bet.
All right, good. So my name is David Paul, and I'm going to be talking this morning about routing and signaling in JMRI. And I guess in many ways, I think this is the journey from DCC to LCC. As obviously DCC was just about control of engines, but now we get into this new field of LCC, layout command control, where we were talking about controlling the entire layout and everything that happens on it. So let me introduce myself. I've been involved in HO scale model railroading for about 50 years now, or over 50 years. I guess it was in the late 60s in New Jersey. I went down the basement one day and found a box of HO trains that my father we had inherited from one of my cousins, and started laying them out, and that was it. So I've been doing that, and then and I have used Digitrax DCC for over 20 years. I don't remember exactly when I got the first Digitrax system, but it was in the late 90s sometimes. My previous layout was designed to have direct current zones, that type of thing, like we knew in the past, and right when in the construction stage it moved over to DCC. So it was in the late 90s. And I've done route control and signaling with custom or specialized hardware, the old transistor arrays that for the twin coil switch machines, that type of thing. And I first started using JMRI about 2 years ago. So at first it was just for roster maintenance and these locomotive DCC settings and keeping track of all that type of stuff. And then it was a layout panel with simple turnout control. So I'll be showing an example of that. It wasn't the more complex thing we're talking about today. And then I started using JMRI for the more complex routing about 3 months ago, and that was in our May seminar. If you remember, we had the talk there about signaling, and we were doing with the JMRI, and Jim was leading that, I believe, right? Is that?
yes, I did.
Yeah,
that.
you led that one, yes.
Yeah, I think that was April.
I have a May 16 in my calendar, but anyway, Jim lit a fire under me, and then I started to look into this more carefully because I've always wanted to do the signaling on my layout. I just hadn't really gotten around to doing it, and so that got me started on that. And so I thought when Jim asked for topics a few weeks ago, I thought this would be a good thing to talk about since I learned so much about how can make JMRI do these type of things in that time period. So here's my disclaimer. So this session is a presentation of what I've learned about JMRI over these last 3 months. I don't claim this is the only way or even the best way to perform these, because I look in JMRI or you go into these online forums and you see they're talking about all the stuff you've never even heard of before. And I'm thinking, gosh, there's a lot more to learn, but at least this got me going, got me off the ground. And so I can, maybe let's adjust the camera here so it's more in my head if I can, here we go. This got me off the ground and got me going. And so I'll be continuing to learn in here and try to test some of the other functions out and see what's going on, but at least this got me started. Okay, so let me tell you about my layout. So the construction started in December 2014, so it's 5.5 years old. I had the major track work completed early 2018, and the 25% of the scenery is in place, approximately. Layout room is about 21 by 19 feet. And the operations can be point-to-point with staging yards. So, I mean, they have the reverse loops at each end, so we can do continuous running, one at the upper level, one at the lower level. And but you can also do the point-to-point if you want to lay things up in the staging yards. All the mainline turnouts, except for 2, are controlled by tortoises, and those 2 are controlled by the new Walther switch machines, and then the manual turnouts in yards and industrial sidings. So like many of us, I've used tortoises for many years, and in my previous layout as well. Then Walters came out with this new switch machine pretty much after my layout was all complete. So I bought a couple of those, and I installed them in a couple places I hadn't installed tortoises yet. I really liked them. So I haven't done a whole bunch of work with them, just those 2, but I did read all about the documentation in them, and there's a lot of good functionality in them. And I was thinking if I had to start over, I might use Walther switch machines rather than the tortoises. I don't know if anybody's worked with those before or has any thoughts on that, but that's just an observation I have. Okay, my Digitrax DCC had the following characteristics. So I have the DCS 200 command station, and I have 9 DS64s and the 2 Walter switch machines controlling the 38 mainline turnout. So for those who are not familiar with the DS64, each DS64 can control 4 turnouts. And of course, when I say turnouts, some of those might be crossovers. Obviously, so one thing is controlling 2 turnouts since the crossovers move together. And so yeah, for the 38 mainline turnouts. And then 2 BDL-168s and 1 BD4. So the BDL-168 provides occupancy detection for Digitrax. And each BDL-168, as the name suggests, controls 16, could do 16 occupancy section detections. And a BD4 does 4. So I got the 36 occupancy sections of my layout. And then the 4 SEHCs driving signals, those aren't all set up yet. Only one of them is set up right now. I'll be setting up the other shortly. And I guess to point out, I haven't set up the hardware, the actual signal hardware in the layout yet. It's just all the logic's in place and everything's set up so that it will work. And that, of course, is a good part of the effort there. And then the LNWI, so I can do the phone control, and the UR92, so I have the radio control. And then there's I've got 10 power districts. Also, I got a picture of what that looks like. And there's a PM42 for those. And then the PS, I didn't check to see the PSX1 and the BXPA1. Got a couple of those. And once again, this is, I mentioned that the PM42 and the PSX1s, I didn't even learn about some of this stuff till after a lot of the layout was in place, kind of like the Walther switch machines. And if I had to start over, I probably wouldn't use the PM42. I'd probably use these PSX1s, since they're solid state, and the PM42s are old relays. And it's just, as things change, you go along, you have to make a decision whether you want to upgrade everything from the original hardware, or is the original hardware good enough? So in this case, the PM42s are good enough. Well, I should mention, I did have 2 PM42s, and the PSX1s actually did replace one of those PM42s. So that's why there's 4 of them. But I was able to determine that the PM42 was good enough for the one remaining PM42 was good enough for the section it was controlling. And then there's the PR3 interface to JMRI, which is a USB connection to the computer, to the MocoNet. And then the Aculite breakout boards. Once again, I didn't learn about these until I was well into the layout. So I got some things that aren't known at the Aculite breakout boards. You'll see that in a second. And then distributed track power panels for turnout operation. So there's about 8 or 9 panels throughout the room. We can have the momentary toggle switches to throw turnouts. We'll see how it all plays together here in just a minute. So here's my power distribution. As I mentioned, there's a PM42, and this is what, if you can see up on the right here, this is what happens when you don't know about the Aculites. So I built that little board with that terminal strips on each side to connect the PM42 to the outside world. Of course, that was a lot of effort. And then I found about Aculites, and it's like, oh, I didn't have to do all this. But so that's the PM42 setup, and then the PXA1's down at the bottom left, and then the Digitrax BXPA, what are they called? BXPs down there. And so that's the 10 sections of my turnout, or the power control on the layout. All right, and then now here's the Aculite breakout board. So this is the BDL-168. So the circuit board's down below there, and this controls 16 sections. And the BDL-168's above there, the green board, and you can see there are 16 screws up at the top there, 4 sections of 4, and those are that's the power out to the 16 track sections. And then on the left, you can see the blue box. There's 4 wires going in, A, B, C, D, and those are the 4 inputs for each of the 4 output sections up there. So the way it works is that you could actually have different power zones. So A controls one of those blocks of 4, B another block of 4, and so on. But you get 16 sections total in there. And then, oh, I thought there was a question. It was just a dog barking. Okay, and here's the SEHC, and this, you can see that multicolored ribbon wire at the upper right. That controls the signal. We'll be showing that a little bit later today and how that all works. But I don't want to get into a detailed description of the SEHC right now. There's Digitrax documentation. This is really good. But you can see that there are 8 places to connect that ribbon wire. So each of those places controls 4 signal heads. So you can control up to 32 signal heads on here. So I can see only doing one of them right now. Okay, so here's some shots of my layout. So just since this is a model railroad presentation, we need to have some model railroad shots. So thanks to Bill Harris. Bill, you're on here, right?
Yes, I am.
Yeah, these are his BNSF units. They came and he came over and we were shooting some photographs a few weeks ago. And so I was building this town. Actually, this is the COVID town for me because there was nothing here when the whole COVID thing started. I built all this and it's not complete yet. And I guess it's interesting to point out I haven't completed the greenery and a lot of other things because once we had that presentation in May, I got distracted by doing JMRI, so I stopped working on the scenery. So I'm going to go back to doing that pretty soon. And here's another shot of one of Bill's BNSF units going through my upper helix. We'll see that here later in the broadcast. And here's a couple of BNSF units passing some superliners. And what's going to that string of 4 BNSF units coming out of a tunnel on my helix and crossing the bridge on the upper part of the layout. And then that's another shot from that town I was just talking about coming through there. Here's a couple of Bill's Canadian National units. These are all scale trains, aren't they, Bill? And then a couple more of those Canadian National units down there over the water on the bridge. And then here's on the Kansas City Southern unit pulling with the George Bush 4141. And then here's some of my units pulling up a train from a couple of older GPs there. And finally, 2 more shots left. A couple of PA1s pulling it's the El Capitan. And then one of our favorites here, this is my big boy and Bill's, I think, Challenger, right? And with the coming through there. So that was quite a production, getting all that to work right. So anyway, there's some shots on the layout. So this has been done over the last 5.5 years. And so now I'm ready to get the signaling in place. And that's what kind of drove me to do all this. So with that, Frank, any questions about my layout or anything that I've said so far? Okay, so by JMRI features, so I'm using JMRI 4.20, and I have a Windows 10 machine by USB to Digitrax PR3. And so I use the roster and DCC programming interface. I'm using 2 panels. I'll show a picture of those. I mentioned that earlier that I had the control panel editor. That was my first attempt 2 years ago, and all it does is really have turnouts on there. And now I'm using the layout editor currently, which is a much nicer interface. I do LocoNet monitoring, which is a really nice feature as well. You can see what's going on in the LocoNet. And then sometimes I'll use a throttle on the JMRI. And then the tables or the objects I use are the turnouts, the sensors, the signal heads, and the blocks and the logics. And there's, as I said before, there are more features in there, more objects you could use, more things you can do with it. And I'll be learning those as I go along here. Okay, so this is my first control panel. And this is my first control panel. I did about over 2 years ago. It's just a track diagram. And we just see those question marks are just because the turnouts hasn't, in this, when I took the screenshot, the turnouts weren't thrown one way or the other, so it just leaves a question mark there. It was when you bring JMRI up, it doesn't necessarily know which way the turnout is thrown. So that's the purpose. There's a reason for those question marks. But I mean, this is fine for a while. You can see the occupancy sections, the different colors, the yellow or white. But I couldn't put any text on here. I couldn't do any signaling on here. I couldn't do a whole lot with it. It was a good introduction to get me up and running in JMRI, and it got me more interested in what else it could do. So here's the layout. Here's how I look right now. So this is since the seminar back in May, I've built all this. Now this is much cleaner, and then, I have to put signals on there. I can put the text on there, and do so much more of this. And so this is what we're looking at today as we go through this presentation. Okay, so turnouts. So I don't know the degree of familiarity with people who have the JMRI on this call, but let me just go through this. So when you bring up JMRI, it's going to, let me bring up I have a problem with the keyboard for a second here. A key fell off my keyboard, and I want to just take a second here to pop it back in. There we go. Okay, so you bring up JMRI, it brings up, oops, let's get back to it. Here we go. It brings up this. And so, and then under tools, you can go to tables, and it brings up tables of all the different things you have, turnouts or sensors or signals or all these different things you can have that JMRI knows about. So this is the turnout table. So this lists all the turnouts that it knows about. And the way I have my DS64s configured, I just have them, I said I had 9 DS64s. So the first one has 11, 12, 13, and 14 is the 4 turnout addresses. The next one's 21 through 24, 31 through 34, and so forth. And you can see here that the state, it also keeps track of the state. So these are all closed over here on these. I can throw one of these just by click. Well, I can't throw that because this is actually a static. But you can click on here and throw the turnout from here if you want to. And so things like 40 though, 30 or 40, those are routes that I put into the DS64. I can program a routing into a DS64, and it also shows up in the JMRI display. But but the state is unknown since there's no physical broadcast of that turnout direction on the layout, unless you went in there and did it yourself. Okay, and then so that's how turnouts are all set up that way in JMRI. If you go down to the next one, signal addresses also are used by turnouts, and this is a key point for later. So signal addresses actually start at 257. And so right here you can see there's a comment, signal head high, low. It's interesting because the JMRI, it will send a C or a T to a turnout to throw it either way, but it also does the same thing with signals. So signals and turnouts use the same addressing in JMRI. So that's important to know. It's important to also plan with your address ranges because, for instance, the first SEC8 is going to have a range of from 257 to, I think, 324. At SEC8, or SE8C takes 64 of these addresses. So, and then the second one will automatically have an address range from 325 to, I guess it's 380, something like that. So, and so on. So when you're planning one of these, it's going to, if you're using the SE8C, it's going to use the signal addresses or the turnout addresses, as I say, above 256. And so it's a good idea to keep your turnouts under 256. You wouldn't have any conflicts in the JMRI. And then there's the virtual signals. So you can see, let me point this out. So there's, in JMRI, there's a concept called the system name and the username. And a system name is a default name that's given to any object, a turnout, a sensor, a block, anything has a default name. And in this case, for the turnouts, I just use a system name, the default name. And it always has a certain format. LT is what turnouts are used for, or what is used with turnouts. Now, I could, if I wanted to, give it a username that's completely my own making. I could say turnout at Long Branch or turnout at Newark or something like that, and call it that. But at least for the turnouts, I didn't do that. I just left them with the numbers because that's how I learned them while building the layout. So I'm sure most of you had a numbered turnout in your layout. You'd know by heart what it is and where it is and what it does. So it's just easier to leave it that way. But L means it's actually on the layout. If you get down to a virtual signal, they start with I. And of course, I have some virtual signals in here because I have some signals that will show up in the track diagram, but there's no physical signal. You know, they might be underneath the scenery or something for going to a staging yard or one of the return loops, which are hidden. And I still have signals on them so I can see where the train is, but there's no corresponding physical address on the layout. And so that's those type of signals start with the I, so they can be physical or virtual. Then you have sensors. Okay, so with a sensor they can be used for several different things. So for instance here, with the BDL 168, its address range in the sensor starts at 801. So your first BDO at 168 will get the address range from 801 to 816, as you can see right here. So I circled that. And so these sensors, they're just, it's like Boolean logic. They're either true or they're false. The thing comes on or it's off. And so when a train enters a section that's in LS 208, it would go to active, and then when it leaves that, it would go to inactive. And of course, it's all done by current detection. So if you don't have resistive wheels on your rolling stock and your caboose and that type of thing, it will go inactive the minute the engine leaves the zone. So you have to keep that in mind, just like anything else we've done with these. But that's one thing sensors are used for. The sensors LS105, 107 are for those Digitrax BXPA1s. And they have another set of range, and those are the default values for those. And then the ones up here are for the DS or the BD4s. So it's interesting because the BD4 and SEC1 is going to get these sensor numbers, 1, 2, 3, 4. And a BD4 on another SEHC is going to get these. And so it's a lot of these numbers are predetermined by Digitrax, and so JMRI just picks them up. So that sensors, but they're not only for track. We'll see what they'll be used for other things as well. And once again, they're used for turnout logic. So I'm showing everything here. So my second BDO 168 has addresses 817 through 832. You can see circled here. And then for track logic, you could also create, and this is the kind of backbone to the whole routing and turnout control we're talking about today, is that you can define a sensor for a state of anything on the layout. So you said, is Gladstone reset? Is upper level lock? Is lower level lock? These are all conditions in the layout that you can define, and based on these conditions in the layout, you can make decisions, and we'll be going to more of that later. So the sensors just aren't for occupancy detection. You can actually set layout conditions. And then these sensors here are actual layout or actual turnout positions. So is LT11C, is LT11T? So those are the two logic elements corresponding to whether turnout 11 is normal or reversed. And I define these, and once again, you have to define these don't show up automatically. The turnouts themselves, I showed in the previous slides, they show up automatically. But if you want these logic elements that record the state of the turnout, you have to define these in JMRI. So wherever I needed these, I defined these. So you can see I've gone for 11, 12, 13, 14, and so on. I've got a lot of turnouts on here that will have this type of sensor describing what their position is. And finally down here, these are buttons on my control panel. So a sensor can also be shown in the panel, and we'll see how useful that is later. So all these correspond to a button you can push to align a route. And we'll dive into that in future slides. And finally, there are blocks. So I'm not sure why, I'll sort of learn why eventually, but JMRI has sensors, but the sensors actually become part of blocks, and then the blocks are what is used to control the signals. So I had to define a bunch of blocks, and each one of these blocks, you go in there and you can say that it's controlled by a certain particular sensor. And it's another layer between the sensors and the turnout and the signal control. But I don't want to spend too much time on blocks. It's only a small part of this presentation. Okay, so any questions so far on JMRI or how I'm using it or one of these elements do? Okay, so now let's get into the meat of the presentation here. So far everything's just an introduction and kind of the elements and how JMRI works. So I'm going to show how to do the turnout and route control. So there are 4 ways to throw a turnout in this layout. So I can do a JMRI layout display, which I showed you just a snapshot of earlier in the slide. So you can go on there and just click on so let's do that real quickly. So here's my layout design. This is the live version. So I can go in here, and since we're doing 54 is going to be a turnout we use a lot today. That's what my examples will be. So if I go just click on that, you can see how the turnout goes back and forth just by clicking that. So that's one way to throw that turnout. I can also use the JMRI turnout tool. So the turnout, I call the turnout tool, is this thing here. So you just type in the number of the turnout, 54, and then you can make it thrown or closed by doing that. Don't use that very often, but it's there if you need it. I also have the local panel. I mentioned earlier I got some momentary push buttons on the local panel, so I can go around and actually 54 is such an important turnout that there's actually a couple of toggles around the room that you can throw manually. So if you're in the room and you need to throw that turnout, you can just click it and it throws. And then of course on the Digitrax throttle itself, my DT402, I can throw it. And the important part is the next bullet. LocalNet and JMRI keeps everything synchronized regardless of how the turnout was thrown. So regardless of how you throw it, JMRI knows about it, Digitrax knows about it, and everything gets synchronized and the states are all remembered properly. So when you're building something in the layout editor, the turnout should be positioned before other tracks are put into place when creating a track editor or a diagram using the layout editor. Of course, I learned that the hard way by putting a bunch of stuff out there, and then I couldn't get to align properly, and then I figured out how to do all that. So you put the turnouts in place first. So in this example, I'm going to create two turnouts, LT52 and LT54 for simulating a passing siding. And I shouldn't say simulate because this is an actual passing siding. So let me do it here. I'll go in panel. I'll do a new panel, panel editor. Sorry, I got the wrong, put it the wrong one. Hold on. Like that, panel, layout editor. Here we go. Okay, so I'm going to go. So I don't know how many of you used this before, but this is how you build your display on your layout. So you click up, you can see all these different elements up here. So you got track, you've got turnouts, you got signals, you got all kinds of things. So if you want to have a right-hand turnout or left-hand turnout or Y, you can do that. If you want to go to track, you can show a track segment. You can put a signal mast up there. We'll be doing that later. And you can also put text labels up there. So with a turnout, let's go ahead and put a right-hand turnout. So what you do is click on here, and you do a shift left click on here, and your turnout shows up. And so then you can make the turnout larger by just dragging and dropping on. I made a copy of it there. I didn't mean to do that. Hold on, let's kill that. So I can go in here and delete it. Okay. Yes, I want to. Yes, delete that turnout from the panel. So I can do a shift right click, and then I can expand this and make this leg longer and so on. So that's one turnout. So now I put a left-hand turnout. I can do the same thing, and then it will create a left-hand turnout. But I want to rotate that, so you can go in here and say rotate, and I'm going to rotate 180 degrees. And there it goes like that. And once again, I can shift and right click and make this as bigger and this bigger and so on. I'll go right off the edge there. Okay, so now we have our turnouts in place. Like I said, you put those first. We make those even. And then I go to track segment. So I'll go to track, and I want to click on track segment. Let's make it a mainline segment. And once again, you hold, when you put the cursor over the end of the thing here, it's going to show where you can.
Look. Oh yeah.
Yeah. Someone have a question or a comment?
Nope.
Okay. And then you do the same thing here. You click on this and you build your, and I'll make it all nice and level right there. That's good enough for what we're doing right now. So that's a basic passing track right there. And it's all done just using these. You click on these different things to get the element you want on there. So that's the passing siding. So what I say next, okay, so we're going to draw these two turnouts for the passing siding, draw the connecting tracks between them, and we're going to assign block names and turnout names to the tracks and the turnouts. So the turnout names, let's go over here. So the turnout name, I said we're going to use 52 and 54. So I go onto the turnout and I click edit, And it gives you a drop-down list, and you pick out the turnout you want it to be. So 52 is going to be right here. And you can also put a block in here. I think the block this corresponds was block 13 or something like that. And I get this warning because I still have the other panel up, but I'll just ignore it since it doesn't really make any difference. And then I can do block. I can call it, let's do this turnout too. So this turnout 54. So same thing, you go up here and you do a drop down. And where's 54 is right here. And I think this would be block 17. Okay. Worries about that. You know, I got the wrong block. I'm thinking it's not critical, but I'd like to get the right blocks on here. Let me take a look real quickly on my actual layout diagram. What the I'll go into edit mode here, and I can see, yeah, this 54 on here is block 11. That was it, yeah. And this is block 10, block 9, and block. Okay, that's it. Block 11. So yeah, this is actually block 11. So let me set this to be proper. And edit, this is block 9. Block 9. And block 10. And there we go. Okay. Now we have a actual sample of this. So let me give a quick example of we can also put a text label up here. So I can say, click on this label up here, and you can type in turnout 54 if you want to do that. And then you would go over here and put this here, and it'd have a turnout 54. And then you go in there and format that, make it larger, change its font, whatever you want to do to that. But I'm not going to do that now since it's not really relevant. And then you go in here and you just, I want to change this one to 52, and I do the same thing. I can go in here and click on 52, and now I've turned out 52. So I can see what turnouts they are, and I can put those on my diagram. Now you see, this is blue, that shows not occupied. Red shows occupied because there's actually a train sitting there. And we zoom in the layout in a little bit, you'll see the train just sitting there in that segment of track. So that's why it shows red. Okay, so we set that up. Now let's go back to here. What we're gonna do next. We're gonna create a sensor that will be used to throw the turnout. So this is what I mentioned sensors before, is that a sensor it's not just for track occupancy, but you can do all kinds of things with this thing. So when you use a sensor, you can make a button. Okay, so let's see. So I have a sensor. I'm sorry, let me create a sensor. Yeah, so we want to go down to the sensors. So let's just create a sensor here, and we'll call it, so you go down here, add, and the name, and these also have these addresses you can do, so, but we'll just call it turnout. Oh, let's just use the username here. What do you call, and hold on, let me get this logo now. Here we go. Okay, I'll just call it turnout 52, 54, just to call it something, okay? So we do that, and now we have the sensor, and you can see it added down here. Well, where did it add it? Should be on here somewhere. Anyone see what that is? I don't see where I put it on here. Make sure it got added. Hold on, let's see. Create. Yeah, I didn't. Yeah, I must not hit create. Okay, there it is. Okay, so something popped up there. It saw the screen reset. Here it is at the top. Okay, so now we have the sensor called turnout 5254. All we do is, it's like defining a variable if you're familiar with computer programming. We just said that's a variable. Okay, so now we have the sensor that's defined. Okay, now we're going to place the sensor as a button on the layout diagram, make it momentary. So when I do that, as I go to, you can actually put a, where is the sensor? Here, the sensor icon. So I go in here and select the sensor icon, which is called turnout 5254. And you can actually go in here and say, click, and now you have the sensor. And it looks like a button, and you want to make it momentary. So basically, it's just like a, you know, like in the turnout signal, the momentary latch is on a switch, on a physical switch. You click this thing, and it's only on for a split second. So you see how it, when it goes yellow, it's just on momentarily. But it's not, it doesn't do anything. Yeah, it just, so it's just a variable that's going to hold some information. Okay, so now that we have that, then we're going to go create a sensor. We're going to place the sensor as a button. Now we're going to create the logic that will implement the sensor, the logic to throw the turnout. So what you need to do now is go into the logics diagram, and I will add a logic. So we can have a, let's just call this throw 5254. And I'll create that. Oh, that's right, system names, you need to automatically generate a system name. I'm gonna do it this way. Okay, so now I have this thing called throw 5254, and this is where the meat of the work comes in here. It's in you want to basically create a condition. So you click on new condition down there, and you can give the condition a name. I usually don't. But if you want to add a state variable, it's like an if then else statement here. So add a state variable. So I say the variable type is a sensor. And so if you're saying if, find that sensor on this list. Here it is. If that's, well, you don't have to, actually you can just type that in. That might be easier. It is turnout 5254. So I'll just type it in. Is turn out 5254, and if it's active, and oh, I'm sorry, if it's active, we update that. Okay, I got it. I must have mistyped something there. It doesn't match any. Why does it say that? Okay, let me do it again. Well, first of all, let's do stuff. Okay. This sensor is turnout 5254. I'm not sure why it doesn't.
Is it case sensitive? You had a small s.
Yeah, it is case sensitive. Yes, thank you. Yeah. I think. Yeah, there we go. Thank you. That was it. It is, JMRI is case sensitive. So yes, everything in there is case sensitive. Okay, so we're basically saying when it has a state, so we add the state variable. So that's like the if part of the if then. So we do that. Now we can add the action. Now the action is going to be turnout. And once again, it gives a list of turnouts, but it's easier to probably just type it in. LT52 can be set turnout. And we can set to close on change to true. We'll update that. And we'll add the action here. Action group is a turnout. And LT54 is going to be set turnout and update that. Okay, so you can see that. So now we have this if. So when the sensor becomes active on 5254, it's going to change both of these turnouts to closed. So let's update that, and we're done. Okay, now let's go back to my diagram that we built. Oops, sorry. Right there. Okay, so now we have the sensor. So right now, it's in the thrown position because it's going around this passing track, as you can see. So if we click this sensor, it throws both turnouts to that position. And that's all that does. And it's just a matter of how you want to set up your logic. So if you go in here, and so now we can edit this, some very useful information. So there's things you can do in here. Let me see where the 5254 one is. Where is? Sometimes it's hard to find things in these lists. Oh, here, at the very bottom. There's a select button over here on the right. So you can say select, and if you want to just look at it, you can just browse up. So you can say, this looks like almost like a computer code there. If sensor is turnout 5254 state is sensor active, then you do these two actions. And so that's also pretty useful in seeing how your logic is set up. So if you go in here and I can do an edit, well, sorry. So let's edit this thing. Let's see. Sorry. Edit. So if I go in here and I say edit the current conditional, for instance, I could go in there and I could reverse the sense of this thing. So we could say set turnout position to thrown, for instance, if I wanted to do that. And do the same thing here. Turnout position to thrown, update that. And then say update, and then done. And you get on the layout. Oops, sorry. So now, if I throw the sensor, it will go to the passing track, like that. So that's just a simple example of how you could use a sensor as a button on here, and you can set up all kinds of logic behind that. That conditional I showed you in this logics right here. So you have this this browse. This could be very complicated. You can have multiple portions of the if. You can have a whole list of actions to do. There's really no limit to the complexity or the fanciness that you could put in there if you wanted to. So one button can do a lot of stuff and to set things up. Okay, and so like I said, so I've done all these, and I'm going to show you some examples from my layout here on the next few slides and how I've used this. That was just an example. I don't have a button that does that, by the way. I just thought it'd be a nice, easy example to show how those two turnouts you could just throw the turnouts around a passing track in one button. But I'm going to show the concrete examples of my layout now and how I actually use some of this stuff. So, okay, so here's the first one. There's three examples. I had this lower helix passenger station. Lower level, I have a lower helix and a passenger station. So if you look up here, you can see it says tracks 102 through 104. Those are the tracks in my passenger terminal, just a stub end passenger terminal. This track here is the main line. Actually goes to a reverse loop and comes back up at the top where it says T31, just a big reverse loop around that passenger station. And then the other two tracks go down to my staging and down a helix to where I do some staging at the bottom. So these are directional tracks. The one on the top says to staging. It's a down to the helix. The one on the bottom says from staging, and it's from the helix. And so basically I have like you can almost think of this as a 7-track throat here coming to this turnout over here, T21, because it's all 7, these routes will eventually end up going through T21. So you can see I created a bunch of these. I created some buttons over here. So you can see right now I create 7 buttons on the left. So I can do any alignment I want or I need to do. And actually one selected right now is track 102. And its sensor name is P2 align. So you can see that's the one that's active and the other ones are inactive. And this one is not a momentary one. I left these on and I'll show you what they did in the logic so that you could actually see on the button which alignment was set up. So you can see over here on the right, you got the logic. So if P2 align becomes active, it does all this stuff. So the first thing it does is it throws these turnouts. So if you want to be on track 102, you can see that 23 has to be thrown correctly, 22 has to be thrown correctly, and 21 has to be thrown correctly. So it does the correct throws on here. Then the other thing it does, it sets all the other sensor buttons to inactive. So if P2 is aligned, we certainly don't want P1 aligned, or P3 aligned, or P4 aligned up here. And we don't want any of these other ones aligned. And of course, it just scrolls off the bottom of the list here, so I didn't show that. But it has 6 inactives because only one of them can be active. So that's how I use this these buttons in this situation where you have a throat and a big yard type of situation. All right, and then I have something called sectional resets. So if you remember on my layout diagram, let me go back to that real quickly. Let me put it back into edit mode. There's 5 sections of there's a Newark, Long Branch, Perth Amboy Mountain. Those are 4 main line sections, and then there's this branch line called Gladstone. So on each of these, I have a button on the right that will just reset the turnout to some default state in their section. And I could do one for the entire layout if I wanted to, but I typically do it section by section because sometimes when I want to, in fact, many times when I want to reset them, there are certain the trains might be sitting on a turnout in a certain section. It would cause a short circuit because you'd be throwing the turnout underneath the train. So I like to be more selective rather than just throwing the whole layout reset as one thing. So you can see I got these resets. So is Perth Amboy reset to button? And that one's pretty simple. When that sensor goes active, and these are momentary sensors, by the way, it throws all the turnouts on that section on the diagram to what I need them to be for the default alignment. So that's a nice feature in that. So let's do a quick example of that. So over here, for instance, Newark division. So if I go in here, I can throw turnouts every which way I want here. Just have a scrambled mess of turnout alignments. So if I want to come down, I say, okay, well, I just want to reset it to a known state. I just go over here and this momentary contact, and if you watch when I click this, all those turnouts will go. And of course, the corresponding signals turn too. We'll get to that in a little bit. And so each one of these sections has some logic like that. Find that very useful. All right, and now the next. What happened to my presentation? Oh, here it is. Yes, there's okay. And the third thing I do is the third thing I. Wait a second. I'm sorry, I'm getting the continuous running. Yeah. So the next thing is the continuous running demonstration. Now so what I have here, let me go to a little bit of background on what this is. So as you look in the diagram here, the Newark division, as I said, where the sensor is set to yellow right now, it's actually a reverse loop that comes around the passenger and comes up here to this segment of T31. And then it heads on to the Newark division, the Long Branch division, Perth Amboy Mountain, until it gets to 73. And at 73, that's like a big upper reverse loop, and it goes around here, and this blue line comes around and comes back in this way. And so there's staging yards at the bottom down here, and you can also go off the staging yards to the top up here. As you can see some of these, like coming off of T82, that's the staging. Coming off of T74, that's some upper level hidden staging, and so on. But in situations where you have guests over, or especially the November layout tour, you just want to run trains continuously. So I've set up by some logic so that when a train gets into the mountain division, once it gets past this turnout here, it will throw it, and so it can keep on running. And the same thing when it gets down to here, when it gets past when it gets past this turnout here, 44, when it gets over here, it will throw it. And so then when it comes back around the reverse loop, it can go back up through 44 and keep going. So the way I do that, and I will show a demo of that here, is we have a couple of sensors. I normally keep these sensors inactive. It's called is lower reverse lock and is upper reverse lock. And you can see right now they're both in the unknown state. So I'll make them both inactive right now. Okay, so put them both, you start out by making them both inactive. And the other thing I have to do is the logics behind it. So if you go to the if you go to the logics, you can say, here's the two logics, and they're turned off. All the other logic is turned on this layout. I keep these turned off in normal cases because I don't want to do the automatic running. and I don't want to have to deal with that. So I just leave them turned off. But for this demo, I'll turn them on. So let's take a look at the logic real quickly before I turn them on. So if you do a browse, you can see what it does. It's pretty simple. You know, there's one of the detection sections in the reverse loop. When it goes active, and of course you're making an assumption that the train is not so long that when hits this detection section, it'll still be over the turnout in the reverse loop. And it's a good assumption. This detection section is pretty far into the reverse loop, and so there wouldn't be any trains that long. So once this thing goes active, it does three things. It toggles the turnout. That's the first thing you'd expect it to do. It also makes, and this is for the lower reverse lock. It also sets the upper reverse lock to inactive and the lower reverse lock to active. Now the reason I do that is you don't want to have a situation where you hit that detection section and maybe the engine leaves and so the detection section goes off, and then all of a sudden the caboose comes there and turns it back on. Well, if you get some type of flicker in there, you don't want it to toggle back and forth. So the minute this thing goes to inactive, it will lock it in that place until the train gets to the other reverse section at the other end of the layout. So using that simple logic, we can actually watch the train. So let's just have some fun with trains now, since we've been talking electronics this whole time. So let me bring up I'll stop the share, and we see Jim with the camera on. What I need to do what do I need to get the camera in place on here? What I forgot.
You have the camera right now.
I have the camera right now. Okay, so I'm looking at. Sorry, I've seemed to lost my controls. Wait a minute. I don't have the. Can anyone see? Can you still see my screen?
I see you.
You can see me. Okay. I want to be able to see me too, so I know what I'm doing, but I don't see me. Let's see. I'm in trouble doing this.
Let's see. Up in the left.
I don't have any.
See. Up the camera up in the tiny upper left. If you click on that.
The camera. Okay, can you see me on? I can see myself again. Can you see me on the screen?
Yeah.
Okay, I'll zoom up here.
Oh yeah.
All right, now there's. Okay, so my layout's now on the full screen there?
Yes.
Yep.
Okay, good.
Beautiful.
All right, so I got a train set up, and then what's going to happen? Well, of course, now I want to share the screen again, because I got to show what's going to happen first on my diagram. So if you go in here and say, you can see right here. Can you see my screen now? The layout diagram,
No.
or is that
Bridge.
still seeing? So I've lost this. Where's the share screen? Oh, here it is. I want to. Here we go. There we go. Now I got the share. Okay, so I think that's a share.
And we got your diagram now.
You got my diagram. Okay, good. So in the lower left, you can see the T73, and that's red there. So I got a train sitting right there, and he's going to come around, and he's going to come along here through 282. And when he gets between 83 and 84, that's the detection section that's going to throw 73 over here. So you'll see the train coming here, hit this, and then he'll come on around and come throughout the reverse and then exit through 73 properly. So I'll show that here. And let me stop sharing, and then I'll show the train here. So let me fire it up. It's going to take a few seconds to. So it's running now, and you'll see up there shortly, but Let me share the screen. Oh, I hope a second here. Where'd he go? Oh, here he comes. Okay. Do you see my layout diagram or the train?
Diagram.
Diagram. So you can see the train is now passed through 73. Now, if I stop the share, you're going to see him coming along on this bridge here.
If you do a side by side, folks, you can see both.
That would be great if we could do that. Yeah, he should be coming in the field of view. See him right up there?
He's lost the controls.
You see him come?
There it is.
There we go.
There's the train.
There's the train. Okay, let me stop him right here. So, just so you can see where he is. So if I go share my screen again. So now you can see the layout diagram. Now he's proceeded up to almost this 82 turnout. So let's just keep him running. And now keep your eyes on the 73 turnout. When he hits that turnout, when he gets to this section between A3 and A4 right here, when that turns red, the 73 turnout should turn the other way.
Oh, yeah.
So he's probably about 10 seconds from there, so zipping across there. I'm gonna run him a little bit faster than I normally would, maybe, to get him over there. Okay, now he's about to hit the 82 section, and 83, and right, and look at 73, and it didn't turn. Uh-oh. Why didn't it turn? Okay, hold on. It worked last night. Did I not turn it on?
The light changed.
You hit active a while ago. When
I didn't make them active. Look, I didn't make them active. Okay, let's. I forgot to make them active. Well, that's a good reason. Okay, so.
Yeah, that's good.
Well, that's our best light of intention. Okay, I'll reverse them real quickly here. Get them past the activation zone. Oh boy. Well, at least it's a good reason. It's not because something broke. Okay, so let's make them both active here. Sometimes you make it active, it actually throws a turnout. So okay. Can you see my screen now?
Yep.
Okay. So, here we go. The diagram. Yeah. So here we go. So now you can see he's about to hit the section between A2 and A3. And hits that, and now it still didn't turn. Okay, this is just Murphy here. Okay, let me, I didn't set the sensor on either. I don't know, let's see. Where's the sensor screen? I'm backing him up right now. Uh-oh. Okay. Well, if it doesn't work this time, we'll go on. But it does work. I'm not sure, of course, it's because we're making a presentation. It makes it not work. So you know how that works. Okay. So let's make this inactive. We'll make both of these inactive. That's the start state. I think I did turn on the logic, didn't I? Oh, hold on.
I can verify this works. I saw it run.
Yes, Bill saw it run, yes. All right, so that logic is turned on, and okay, here we go. Let's run them back again. Okay, and there it goes.
There it is.
There through the turnout. Very good. Yeah, I just have to make sure everything is set in the proper set. Anyway, so that's kind of useful if you want to keep some continual running. I don't use it that much, but it'll be useful in the November things. So,
Hey, David, got a question.
yes. Mm-hmm.
This is Alan. looking at your diagram there, you've got the sensor set on the main line. If you were to go through that passing siding, would it still work, or would it bypass that sensor?
Up here, no, it would not. This is actually a real short siding. It's just enough to store like 3 or 4 passenger cars for a little. Yeah, so it does not work in that because would normally not operate that way. But you could, and I could make it work since there is a actual sensor on here. You could do that also.
Okay.
So,
thanks.
Yeah. Okay. And so that's okay. And the other thing I wanted to show them was JMRI startup. I didn't mention. So let me stop this train. So when JMRI starts up, okay, so you have all this here. It's one of the things, the way these, well, if I turn this off, we're going to lose everything. Well, I'm going to turn off JMRI and start it back up. Well, I don't want to do that because that will lose my board. But when JMRI starts up, a lot of these signals, a lot of these turnouts don't have any state. It just shows them as continuous track. It doesn't know if it's thrown or whether it's normal or reverse or anything like that. So that's another reason I have these buttons over here. So even sometimes you push the button, it will actually validate the state of the turnouts. Even if it doesn't throw them, at least on the diagram, it will throw them to what they actually are, which is also very useful because when the thing starts up, if you don't know which direction the turnout is, it's not very useful. Maybe I'll do that at the end once we finish over the demonstration. Okay, so with that, are there any questions about routing logic? Okay, let's say that's turn turn it back to me here since we're gonna. I guess about the routing logic I really like about this is that it's not dependent on hardware. I have my tortoises and my DS64s, and that's it. And it all hooks into the PR3, goes to JMRI, and I can pretty much align anything I want just through software and not have to worry about doing hardware or anything like that. Now, the one exception I do have is my lower level. I have the lower, where I do some lower level staging. It doesn't show up in that diagram because it's just a staging yard. But I do have an old transistor array that I salvaged from my previous layout that I use just because I salvaged that. I salvaged some twin coil switch machines. I thought I'd just reuse that stuff. And so it's not worth tearing all that apart just to get into JMRI control. Although there might be a way to do it without tearing it apart. I might be exploring that sometime in the future. But for me, it's just very, very nice to be able to do all this in software and not have to worry about the hardware of transistor arrays and doing other things. Okay, so the final part of this is signals. Okay, so signals can be physical or virtual. We talked about that earlier. And you use a virtual signal if you want one in your diagram. So let me show my diagram real quickly. So over here, by T11, these are under a helix under the layout. So it's nice to have these there. You can see the train progressing. You can see signaled indications of what's lying ahead, but there's no physical signal since you can't see it. So I've made these are actual virtual signals right here. So signals could be either way. The signal logic uses turnout position and sensors to determine the proper aspect. So just like you'd expect, it looks at what sections are occupied and what the turnout position is. Signals can be thrown from Digitrack throttles in a similar fashion to turnouts, and we'll demonstrate that. It's kind of interesting how that all works. And then Digitrack signal uses the turnout logic, C or T, to control signal aspects. And if you remember back in those first slides about turnouts, I showed you how the signals use turnout addresses 257 and up. So like I said, the first SDHC uses 257 through I think 324, something like that, and the next one uses 325 through 380, and so on. And so but it uses the same objects that turnouts use. And then each signal has an edit logic feature that completely defines behavior. I'm going to show you that in the next slide. And then we're going to do an example of what I'm going to do. So the next slide, next slide is this. Yeah, I got them out of order. So yeah, so when you go into a signal, let me do that real quickly. You can bring this up to edit the logic. So So if I'm on my layout editor, I can like right click on any signal and type edit logic, and it brings this up. And that completely defines this, the behavior of the signal. And so, and let me, before I go on, I know there's ideas of signal masked, and there's more elegant ways of doing this, but this is the way I've chosen for mine right now. I'm going to try to learn more about this, and but I know there's others, maybe more prototypical ways of doing this, but this works for me, so I've gone with it for now. So this top part in the blue line, this defines the divergence of the turnout, whether it's a main or a diverging leg. Really, when you click between main and diverging, it just changes this from thrown to closed. So obviously, if you're on the main leg of a turnout, if the thing is thrown, like it shows right here, you want the signal to be red. If I chose to be diverging leg, this would be changed to closed. And then the single block takes away this completely, because that's just on a single piece of track where there is no turnout. So that takes away this line. And so I use these three. I really haven't used the facing point turnouts, but I use these three in my layout to find the signal logic. So as you can see, so this turnout is basically, if this turnout is thrown in this direction, it's red no matter what, because the track's not aligned for that. More interesting is this red part, this thing I circled in red. These are the sensors, and this is where the real power comes in. You can make it so if any of these, this means if any of these sensors is turned on, it will go red also, because that, so like for in this example, sensor 815 is the next section. So if you go through turnout 54, and if next section 815 is occupied, you're going to want it to be red, so it'll turn the signal red. And then you can have not just one of these, but you can have multiple of these. And I'll show you how I use that. And that's one of the most powerful feature of this, is you can have multiple conditions that'll make it turn red there. And then signal that protects the signal, this is what sets up the yellow signals. So this is just the next signal down. So look at the next signal and say, if the next signal is yellow, it will also make yours red. If the next signal is a flashing yellow, it can make yours yellow, for instance. So it just looks at the indication of the next signal to figure out where what should be done. So if the next signal is red, it would be yellow. So that's how the yellow signals are implemented with this part here. So on this screen, you can define everything you need as far as the turnout logic goes. Okay, so the physical signal demo. So here's what I want to do. So in my demo, I have addresses 261 through 264. And I tape this signal up here. This is an actual Digitrax that's signal. Let me put this little black background here so you can see this better, and I will zoom up to it. Let's see where it is. Okay, can you see that? It's
Yes.
yes. So so what this signal corresponds to, the green head, the top head, if you look down here, long branch division top signal, that's the green you see there. And the bottom head that's red now, that's the bottom signal you see here. So that's a physical representation of these two signals on the layout. And you can see here, I'm using LT 261 through 264. So these correspond to these turnouts, 261 through 264 on here. So you can see right now, you got thrown and closed, thrown and closed. So they're all set up that's what sets up those two colors in JMRI, is that combination of thrown and closed on 261 to 264. So the 261 toggles between red and green, and 261 toggles between red and green, 262 toggles between yellow and flashing yellow for one signal, and 263 and 264 for the other one. So the SE8C does not have any logic on its own. So let me show this. Where's my turnout thing? Right here. Okay, so you can see my turnout thing. So I can come in here, and I can say 261, and I can now watch the signal. If you can still see that, I believe. I can say, see how the bottom head now. So 261 toggles that between red and green. Thrown and closed. Thrown is red.
Could you zoom in a
Close.
little tighter on that signal?
I know. I think it's zoomed in max right now. That's the problem.
Okay.
Let me do this. Yeah. Right here. Here we go. hold that up. Now you can see it better. Okay, so once again, thrown is red, yellow is closed. If I go to 262, that toggles between thrown, which is yellow, and closed, which is flashing yellow. So that's how it works in the Digitrax rule of the SEHC. Now if I go to 263, the same thing for the other signal. So I can do thrown is red, closed is green. Thrown is red, closed is green. And 264, same thing. Toggle between yellow and flashing yellow. So you got the yellow, and then closed is flashing yellow. So that's what I say. There's no logic in the SEHC. I guess I thought when I first got in here that Digitrax had set up a system to do logic in their signals, but no, it's just a hardware system, and it's really nice as far as you just plug the signals in. Of course, the signal doesn't look like anything prototypical, and that's one of the problems here is that it's just a circuit board with some LEDs on it. And I've been trying to find purchase signals, but a lot of places seem sold out right now. I guess maybe during COVID, maybe some of the suppliers, they aren't getting some of their supplies or something. But I'd certainly like to get some more prototypical looking signals on here and working with these. But for now, I'm just using the Digitrax. And maybe it's possible to actually decorate these, put some hardware around it to make it actually look like a prototype signal. But this doesn't look like a prototype. Back to the logic. So from a pure point of view of just toggling turnout, you can make it throw nonsensical. It doesn't matter what you put on there because it will say, so if I say closed here, that's green. I go 263 and say closed. So I say closed here, and what do I have? I have a green over green, which of course is a impossible situation. But from just from a port of signal hardware on the Digitrax, it doesn't care. It just takes commands from JMRI and sticks up an indication. It could care less if it makes sense or not. But JMRI, though, on the other hand, so if I go to 54, now since this signal, the top signal for 54, and the bottom signals for the two routes going into 54, if I go in here and I now go to 54, so you type in 54 on this turnout, I close that. It immediately changes it to a sensible indication because when you throw a turn on 54, it resets all the signals associated with that turnout, so it sends out new commands. And if I go to the thrown state, it should just reverse them, like you see there. So closed, and then thrown. So that's basically how the signals work in Digitrax. Let's put this back.
Got a question for you.
Yes.
My initial plan was to do the signaling, the individual signals off the tortoise machines for the turnouts.
Mm-hmm.
Do you have each signal connected to your tortoise, or is it truly controlled everything through the Digitrax logic boards and your JMRI?
Yeah, it's all JMRI. I don't have any signal logic controlled through the tortoise or the DS64s. It all comes through the SEHC.
Now, why did you go that route, though?
Well, I guess in the beginning, it's kind of one of these hybrid things. As you go along, I thought I've always wanted to do signaling, and I just thought I would do the Digitrax signaling, and I'd use the SEHC, but I didn't really look into it that carefully. And then I got to the layouts complete, and everything's working. And I said, okay, I'm going to start looking into this more, and I just basically followed along what Digitrax said. I'm not through a tortoise though. So you're saying, how would you, so when you switch the torso, it would switch it from between red and green. Is that in the tortoise?
Yeah, you could hardwire your signals to the tortoise motor and make them just track your turnout.
Right, correct. That's what I'm saying. Is it just red and green? Is all I'm saying. Is this a simple, very simple, just two-way logic? It's red or green. Is that? Who was asking the question about the?
This is Jim. I was asking the question. I got lost on my phone, so I apologize for the delay.
So you're just talking about a simple red and green indication. So turnout is, the line one way or the other for a.
Right. You would use a combination of the tortoise signaling off the individual turnout, and then use the JMRI to control your sequence of signals, you know, for your routing in that.
No, so I chose this. Okay, so I wanted to have the advanced logic because I got some situations here that are more complicated. I'm going to show those in just a minute. So I just wanted more than simple red and green. And I suppose in my previous layout, I used something from Logic Rail Technologies. If you're familiar with that outfit, back from 25 years ago, and they had similar type logic where you basically program these signals based on the turnout position and occupancy in future blocks. And so that just seemed like the natural thing to do here. So I never really considered doing it with a tortoise or anything like that. I always figured in the end I'd be doing it using some type of digital logic to make it happen rather than wiring it through the hardware. So that's the main consideration there. And for the more complex situations, which I'm going to show you here in just a second. So there's the signal, there's the basic signal logic. Okay, so here's the more complex situations I'm talking about. So on my lower level staging connection, we saw this earlier. I have this lower level thing. This track goes to staging. This track comes up from staging. So what I want to do is I put this signal here on T11. So the green indicates that the straight ahead is clear, like it is in the picture. Or this lower head would indicate green if it was on the diverging route. If it was on the diverging route and down to staging. So even if it was on the diverging route, but was coming up from staging, this would not be green. It's because it can only be green if it's going through here, through T11, and then on to T12 down to staging. And then the same thing here. This signal here is green if it can go straight through here, which it is right now. And this signal is red if it can come up from staging, like it is right now, and go onto the main line. Of course, it's red because it's not set for the main line. So, and to that, hold on, and that requires a special logic to do that. So what I did here, so you can see the logic. So for T11 and T12. So right now, so I circled this signal, this red signal, because that's what this example is showing. So I say diverging leg of the turnout because you want, if the state is closed, which it is right now because it's going straight, you want the signal to be red, which it is. It protects the sensors at L12T. So L12T is one of those sensors I set up. I showed in the slides way back there to show the indication of this turnout. So if L12T is thrown the wrong way, it's going to be red also. And so really that's just the two conditions to make this that determine the signal. It's the, I should say three conditions. It's the, I'm sorry, it's the state of this turnout here and the state of this turnout here. And then I use the sensors to make that happen. So here's the logic and the logics. So you can see that when LTLT is LT12 I should say, is turned to thrown, and then it can set up this logic here for L12T and to be active. So that's the logic behind this sensor right here. So like I said earlier, I did a whole bunch of these type of logics for each of the turnouts that I needed to have this advanced logic on. And it's a real simple thing. It's just, when it gets thrown, it sets this L12T to one thing, or if it's thrown the other way, it sets L12C to a certain value. So that's what the logic looks like. So if you go to the layout diagram on here, you can see how this is it right here. So right now it's like you see in the diagram, but if I throw this turnout, now it goes red over red here because even though the diverging route is set to red, it's not going to take you down to the staging yard because we don't want anyone going down this way to the staging yard. They'd have a head-on collision with trains coming up. So not until this throws the other way will this actually be green. So that's kind of one of the special situations I put in place there. So and then once again, if you throw this back to green, then it's green over like you'd expect. These two, the top head and this head behave just like you'd expect. So that's one of the special situations. Okay, next special situation, the passenger station. So in the passenger station, I have 4 tracks, and I'd like to have a signal showing which track was actually the aligned track for the going out to the main line. So I got 4 turnouts here. the main line in 21, and then the three turnouts going into the 4 tracks in the yard. So you can see what I did over here as I set this thing up to protect sensor 809. Now 809 is this train is the actual block indicator on right in here on 21, because certainly don't want any trains leaving the yard if there's a train already out there in 21. So that's why that flows at red. And then let's the 23. Put this over here, because also 23 and 22 are in there as well. So 23 has to be set properly, and 22 has to be set properly, and then 21 has to be set properly right here. So it's obviously going to be red when 21 is closed. All these will be red when 21 is closed, because if it's on the main line, none of these trains from the passenger station can exit. So basically, these signals here are determined by one layout occupancy detector, which is 809, and the positions of 3 turnouts, 21, 22, and 23. So if you go to back to the layout, you can see that and you can combine those with the buttons right here. So I can click on that button and say that turns green. Or if I want to go to this track 4, you can see I click that and it goes green. And if I want to go back to the main line, they all go red because it's aligned for the main line. So that's the other special situation here. And like I said earlier, having multiple sensors here really is useful, because then you can have all kinds of logic situations to determine how these signals should be aligned. And then the final example I hear on signals is at long branch. So in this example, you got a 3-headed mast right here. You got green over red. So the green is for the main track through here. The second signal red is for this passing track through here, through 52, right down through here. And the third signal is for this 51, which is just a passenger siding, so a passenger train can sit at the commuter station. So you want this to control these 3 tracks. Plus you have this turnout here, 13, which leads to my branch line off to the left. So certainly if 13 isn't thrown correctly, all 3 of these have to be red, because no one can proceed from here. And so that special situation, the sensor at 13 is LS4. This is one of the BD4 sensors, is right here. So certainly if anybody is occupying this track right here, these all have to be red. So that's why that's set that way. But besides that, the signals are determined by what's with 51, 52, and 13. So 13, 51, 52 will determine the position of the circled signal. So it's this one here. So we're going to say it's red if the sensor is occupied, if 51C is thrown the wrong way, if 52T is thrown the wrong way, or if the LT13 is thrown, this signal will be red. And let me show you that on the layout. So you're talking about right here on this long branch division. So right now, if I throw 13, all 3 of them go red because it's blocked. But if I throw that back, that clears 13. And now you can see that the passing track through here that goes through 52, that middle one's green because that's the route it has. If you throw 51, then it throws it so that the direction is down to this little passenger station siding, and it's yellow. I also set the yellow because if you're going down that track, you're going to be stopping at a passenger station, so you don't want to have a green. You want to have a restricted indication here to get into this passing siding or into this passenger track right here. So that's the other special situation there. Okay, so yeah, those are 3. There's still some others on the layout, but I thought these examples were enough to show some of the enhanced logic. And once again, this is all done. The one I like, just like where I talked about the turnouts and routing before, you don't have to do anything special on hardware. You wire up your signals, the SDHC, and all the signal logic is done inside the JMRI software, and so you can have a lot more flexibility doing that. Okay, so any questions on signals?
David, I have a question. So I know the Digitrack system was set up around a single turnout OS section. So
Right.
when you run into these signals that have a 3 head on them for a more complex situation, you're just having to use another port for another head. Is that correct?
That's correct. I haven't actually physically done that yet, but that's what I've set up my system to do.
Right, because of the 8 ports, you get 4 signal heads each.
Right.
The 4 signal heads are set up for a double going into a switch and a single on either track coming out of the switch. There's your 4 heads, but if you have to use a triple head, which I'm going to have about 4 of those, you do have to use another section for another head. Is that correct?
Correct. Yeah. So let me show you something here. Hold on. What? Yeah. I probably should put some of this in here. So I have a spreadsheet. It has all kinds of stuff in it, and one of the things I have is, let's see, where's my? Here we go. I keep track of how much time I spend this layout. By the way, if you want to look it up, see column C. Add that up, it's 1,420 hours. So anyway, but we didn't want to know that, did we? Okay. Anyway, this tab for the SEHC. I find this very useful too. So if you can see right here, this is the first SEHC. So it runs from 257 to 320, the 64 addresses. And so, like you're saying, yeah, this is the first head around that signal, that turnout 54 we were just talking about, and so on. So yeah, where I got to that triple head, that is down right here. Yeah, this 51A2A3. That's my. So yeah, I'm planning right here to use 2 of these. To basically, I use 2 of these blocks for. I'm just saying, one block will control 3 heads, because right now one of those blocks can control 4 heads. So I'm just going to have that one block control the 3 heads and just leave the other one unused to keep things simple.
Okay.
That's basically what I'm planning to do there.
And I like your list, by the way, too. That's a great idea.
Yeah, thanks. It's I have yeah, like you can see here, so I keep track of my blocks. I keep track of the PM42s and have their settings and all that. The BDL 168s, all the sections here. I mentioned there are 32 BDL 168s in the BD4. Keep track of what block each section is mapped to and what so. So, yes, I certainly would recommend doing this. And by the way, this is all planned out. None of this is implemented physically, really, except for the example I showed here, which is what, 261 through 264. So, but it's not even implemented on the layout. I just plugged it in to show this demonstration. But yeah, so I'm expecting I'll probably, when I get into the real world, I might have to change some of the around, but at least I'll keep it as I have track of what I've done and be able to better figure out what I need to do. So anyway, good question. Thanks. Any other questions?
Hey, David, it's Kelly. Hey, so what you just said was you've got all of your logic and everything built inside JMRI, but you don't have any of the signals yet on the railroad.
Right.
But all of the sensors are on the railroad and your turnout controls are on the railroad.
Correct. So the sensors are on the railroad, all coming in the JMRI. They have been for the last 2 years. Since I started putting them in place. The SEHCs are in place now. Well, not all of them. I'm still installing them, but the one I think I said I have 4 SEHCs. I have that one that I just showed the demo on for this signal. That's in place, and the other 3 I'll be putting in place here in the next few weeks as I get around to doing that. So the idea there is the SEHCs in place. Then once. My preference is to not install the signals until the scenery in that area is complete. That way I won't have to worry about knocking them over and making a mess on them. So I'm planning that the parts that are scenic, I'm planning to try to get the signals up there as soon as I can, as soon as I find some signals that I like. But for a lot, that's only a handful of signals though right now there in the scenic area. That signal 54 that we were just showing is in there. And then there's a couple up on the HELIX. So there's only about 10 signals I can put, 8 or 10 signals I can put in that are actually on the scenic area. The rest of them are unscenic. So I'm planning to, as I do the scenery, install the signals. But the nice thing is I just have to install it and plug it into the SEHC and it'll work.
So you haven't run any of the wires yet out there to the signals yet either.
No, I have not. The 10. That's the what Digitrax has is this ribbon cable. Let me see, get an example of that down here. Where is, I don't want to make a mess down here trying to find this, but here we go. They sell this.
Okay, stop sharing your screen. Let us see it.
Yes, okay. Stop sharing this thing, yes. Okay. Let me go over back to me. So this cable right here, you see this is a 10 conductor cable. And they sell this, and basically these 10 conductors, you see let me go back to my slideshow. And let's share the screen again, hold on. Where's the share? Here it is. If I go back to my slideshow.
David, where are you getting the ribbon cable at? Are you buying that from Digitrax? I think it only comes in 30-foot links.
Yeah, let me adjust that just a second. Can you see my screen now? Okay, so if you go back to the top where I have those pictures, right here. That's that 10 strand ribbon cable. So you need one of those for each of those 8 outputs on the SEHC. So yeah, so that ribbon cable, yeah. So I was buying that from Digitrax. I bought a couple packages to get started. Then I was looking around the allelectronics.com. I don't know if you used them before or not, but I was buying some wire, just general wire for the layout. I had some things in order. I had to buy some terminal strips or something for non-layout uses, for home use. Then all of a sudden I saw this thing pop up for a 10-strand cable. And I got curious about that, so I started looking into that. And you can order that and buy the foot for much cheaper than you get from Digitrax. Now the only thing is, it doesn't have all these pretty colors on it. It's all gray. In fact, let me, right here. So can you see me again or not?
I don't see you on the side. You're still sharing the screen. But.
Yeah, you see that?
Yeah.
Yeah, that's the one from allelectronics.com. And so I bought that just to see if it worked, and then just a couple days ago I finally tried it in preparation for this presentation, and it works great. In fact, the signal I'm showing up behind me here that we've been looking at is powered by that cable. The only downside is that, yeah, Digitrax will say the cable, but there's also a connector, like a crimper thing where you actually have to put the, let's see. Yeah, so at the end of the cable, you have this black connector that plugs into the, right, that plugs into the board. That also comes with Digitrax kit. I don't think they sell those individually. So you're going to have to buy a certain amount of Digitrax cable just to get enough of these pins to crimp onto that cable and connect it to your system. But I do have some pretty long runs. And the 4 SEHCs, I tried to place them strategically around the layout so the runs wouldn't be too long. Mm-hmm. And I might have been able to squeeze everything into 3 SEHCs, but some of the runs would have been tremendously long. So I thought, I'll just bite the bullet, buy a 4th SEHC and just make it more manageable from the wiring point of view. And so I was concerned about how much cable I'd have to buy, but it's good to see that I can get this at allelectronics.com for probably, it's hard to make a comparison because in the Digitrax gives you a 30-foot length of cable plus about 8 or 10 of those crimp things. So, and that costs like $20. So it's hard to say how much of that's wire and how much of that is the connectors. But right. The allelectronics.com, I think, was like maybe 20 cents a foot for the 10-strand wire. So for $30 or for $20, you could buy what, 200 feet? So something like that, or maybe 100 feet.
Like I said,
whatever
I've
it
got
is.
one run that's probably going to be 70 feet, and 30-foot cable is not going to cut it.
Yeah. So so go to allelectronics.com. You can find, and they'll sell it to you by the foot, and you buy as much as you want, as long as you want. So that I think that's a pretty useful idea there to do that. But certainly if someone finds a way to, I don't know if those Digitrax connectors are proprietary or there's some type of standard industry thing, 10-pin plug you can put in there. We could crimp on the cables, but if you could get those from a third party, that would really cut down the cost because obviously Digitrax marks that stuff up, sells it probably for a lot more than it actually needs to be.
You can buy it separate. I just have to remember the source.
Was that buy them separate? And
You can buy them separate. I just have to remember the source.
oh, for those little black connectors?
Yeah.
Well, if you remember, yeah, let me know.
Because
the other thing I do is what was that?
they come in various sizes too, like 10 pin, 16 pin.
Uh-huh.
Yeah, when I was looking for them for the other thing I was working on, the 10 pins are different sizes too. So you have to actually look at the millimeters between the pins and the size of the 10 pin connector, or they won't plug in right either, Bill.
Yeah.
Right.
So yeah, if anyone finds those, let's share that knowledge because the problem I have, in fact, last night when I was setting up this demo, I broke 2 of the stupid things. They're kind of difficult to work with. So I'd hate to sit there and just have to spend $20 because I was down 1 or 2 connectors just to buy a whole new package of wire I don't need just to be setting up connectors. So yeah, that'd be a good thing to know.
Of you.
Okay.
Model railroaders are resourceful.
Yes, they are. It's amazing with the things you can, some of these websites, these third-party websites, you go out and find exactly the item that some model railroad vendor is sending and marked it up 2 or 3 times as high as you can get it elsewhere. But
And usually pretty cheap.
and usually, yeah. Oh, any other questions? Okay, so here's some of my learnings. Just always want to go over these at the end. Talk about, so don't skimp on detection sections. So do you know that I had 2 BD0168 to 1 BD4? Well, I have a BD4 because I had to add in some more detection sections once I started getting into the signaling. And I started to put the logic there, and I thought, this would really work better if I had some more detection sections. And so the BD4 is actually pretty nice because it actually hooks into the SEHC. So once I had the SEHC in place, I could just run the BD4 into it. And the SEHC will also control turnouts, just reading through the documentation. So it's possible if you set this thing up from the start using an SEHC, you might not even need DS64s, just depending on what you're doing. But I haven't tried that myself. I just read about it in the Digitrax manual. So don't skimp on the detection sections.
It does work good.
What was that?
I'm using the SC8s for turnout control, but not signals yet.
Okay, yeah. So how many you can control? 8 turnouts in SEHC or 4? I don't remember the number was. You could do 8. So of course 8 turnouts, yeah. And that works great. That was
yes.
Yeah, good. And for the polar turnouts, not this twin coil turnouts, right? Is that like for the tortoises?
Yeah, it's not a twin coil.
Yeah, okay. And once again, if I had to do it all over again, a lot of this stuff you learn as you go along, but you have to make the decision if you want to change what you've already done in the past, if it's worth it or not. Most of the time it's not, but sometimes it is. It's like in that power distribution board I showed, I had the PM42s. I got rid of one of the PM42s when I discovered these PSX things from, what's the company that makes those? Someone on here certainly knows. PSX ARs and I'm trying to remember, DCC Specialties, I think it is. So, but then, and with the SEHCs, if I had known the SEHCs control turnouts when I first started this, maybe I should have read the documentation when I first started. I might have used those instead of the DS64s. So maybe that's another learning, is to learn about all your options first instead of maybe don't get settled on a certain path, a certain way of doing something. Okay, next thing is have a naming convention for all these objects. So you've seen on there I've had a lot of names for sensors or for logic elements or for turnouts, things like that. So you want to have a naming convention, a numbering convention. I have a naming convention for my signals, a numbering convention for the signals. So that all is very helpful. And I maybe should add on to here what was mentioned earlier in here, is having a spreadsheet that records all that stuff. I've gone back to that so many times, and I always strive to keep that thing updated.
David, let me step in here for a second.
Mm-hmm.
Mark, if you look in your chat window, Mark has actually given the link to those 10-pin connectors. Okay, just so everybody knows that that's in the chat window. So you might capture that before you
I
leave.
definitely want to capture that. Let's see. So, Mark, are those actually, do you know those work, or as far as the chat window? Where's the chat window on here?
Very bottom.
Very bottom, huh?
They look the same. I don't know if they work or not. They work on a 1/10 of an inch spacing, 2 rows of 5.
So, Jim, can you grab that link and maybe send it out? I don't want to delay the presentation here looking for the link and stop.
Yeah, it should be captured. I'm recording the session.
Yeah.
And I popped it up on the screen, so I think it'll be captured.
Okay.
If he takes it out of full screen mode, he can see the controls.
Yeah, I got full screen mode. Let's see. Now, don't want to mess with it right now. We'll get it later. Okay, so then my next learning is make frequent backups. Sometimes you'll do something in JMRI that you later regret, and it's easier to throw it all away and start over from a known version than to try to back things out. And so, well, obviously you save all the time too, because JMRI can crash, or you can have a power failure or something like that. So I'm always saving my work to make. But beyond just the simple saving, back up known good copies into it. Take the XML file and take it somewhere safe where it won't get messed up. So because so far I haven't, and that has actually bailed me out a couple of times. So you can't. You're not paranoid about backups if you need to use them. So
I would also recommend that you make a working known good profile that you operate from, and then when you want to do an addition of something, that you copy that profile to an experimental one, do all your changes there, and then rename it back to your primary one when you're confident of what you've got.
Yeah, so Jim, so you're mentioning that to me earlier about the profile. So you can go to preferences right here under the edit. Oh, I think I've already got the preferences up. Where did I put it? Oh, there's too many windows up here. Let's see, preferences, here they are. Okay, so in the preferences, you can go to this config profiles, right, what you're saying, and then you can actually add a new profile here and copy an existing profile to a new profile and then work from that one and leaving your old profile unchanged.
Yeah, that's correct. That way you can go back to working with your known good profile, and then when you're confident of all your changes, you can start using that as your main profile. But it leaves you in a state where it's like software, right? When you go download a lot of this free software, they give you the latest release, and then they have the experimental versions, right, that you can download, right? And so you can always go back to a known state that way.
Yeah, that's
You have multiple releases then, right? Release 1, release 2, release 3.
That's correct. You can keep them that way too.
Okay. Yes, and thank you for that. That's a better way to do it than just making copies and sticking that in a disk somewhere. It's just to use those other alternate profiles. Okay, and then the next thing is learn by doing. So I came in here, what I showed you there with that signal spreadsheet, for instance, that's not the first try of all that stuff. And the logic, that's not first try. That was after banging my head against the wall and making a lot of false starts until I figured it all out. And then learn how to edit the JRML XML file. So for instance, when I was showing that spreadsheet earlier right here, well, here it is, yes. So I figured all this out, and I figured out what signals I want with which addresses and whatnot. So then I basically just went into the XML file and added the signal so I wouldn't have to create each one by hand in there, because you can see there's 4, as I said, there's 4 SEHCs. You can see there's a whole lot of signals that need to get created. And doing each one by hand, it'd take a while to get it done, but it was so much easier. With an IT background, I can manipulate these things real quickly, maybe even write a macro to spit out a whole bunch of these things at one time. I was able to go in there and edit the XML file to actually create the signals in the file. So if you feel comfortable doing that, that's a good thing to learn. It's also good to know just how that works, because I have run into problems before. I had to actually go fix something in an XML file. And sometimes you can, if something has a bad name, really the only way you can fix it is by going to the XML file and maybe changing the name of it in there. So there's certain things that aren't very manageable in JMRI as far as naming goes. I had to get, that I knew about at least. I couldn't rename certain objects. I had to go in there and change the names in the file and then reload them.
Hey, David.
Yes.
I haven't started building my system yet. Could you share that the form of your spreadsheet?
Sure. Yeah. Who's this? This is
This is Alan.
Okay.
This is Alan. It would probably help me to keep it all straight once I get started on it.
Okay. Well, Jim, do you want to send it out to the group, or just send it to Alan, or how we want? Because we'll share something.
Why don't you send me a copy of it, and then I'll put it where the group can get to it.
Okay.
Appreciate
I'll do that. Yeah, I'll do that. Okay. And then I joined the JMRI online users group, and this is an IO groups, and there's a bunch of the JMRI developers and the gurus, as we would call them, in there. So, and I've had several issues and questions answered that kept me going, because a couple times I got to a stopping point, I couldn't figure out what to do next. So I just put it out there, and usually within a few hours, somebody responded and said, oh, here's what you need to do, or here's what the problem is, that type of thing. So having a group like that is very important. And then finally, future projects in my layout. So thinking of things for those buttons I showed you, the buttons they're just little tiny buttons. I'd like to make them larger, maybe change the icons to make them more like buttons, or make them easier so you don't have to get the mouse so exactly on them, for instance. Complete the physical installation. We just talked about that. As I do the scenery, I'm going to be putting in the physical signals. And of course, the signals become available. I've just going online, had a hard time finding signals. Everyone says they're out of stock. And then specific preset route alignment buttons for operations. So the buttons I showed you are just kind of general resets. Yeah, here's how you set the staging track to the one to get out of the staging yard, or here's how you reset an entire section to some default thing. But there are certain routes we take in operations which aren't standard. They might have to throw some turnouts in a particular way to get from one place to the other. And so when we have operations, we have a dispatcher, he could sitting at the panel, he could actually push that button and line everything up. So that type of thing. And then updates to run lower level staging ladder out of control from JMRI. I mentioned that earlier. I still have some transistor arrays down there controlling some twin coil switch machines. But I think I see a way using a DS64, maybe the SEHC, to actually throw the turnouts through the transistor array without having to tear everything out and just start over with new hardware. So I might get around to doing that at some point.
I could help you with that too.
Okay. Well, yeah. Do you know what I'm talking about then? So the transistor array, you have the thing where you have a momentary contact in one of the inputs, and it lines that has the transistors that, or I should say, I mean diode arrays. It sets up the diode so that only the certain turnouts will throw a certain way.
I've done that for the club. It's a lot of fun. We can do it and leave your local button still active too.
Okay. So you did it through JMRI then, that way?
Yes.
What did you use? Did you use DS64 or something else? Or
I used CMRI.
CMRI? Okay.
Yeah.
Well, good. We'll talk when it's not a high priority project, but something I want to get to eventually. So yeah, I'll look you up when it's time to look at that one. And then layout lighting control as we get into more scenery, maybe be able to turn on and off lights in buildings, non-train objects, things like that. And then the last one is a logic to run 2 trains simultaneously. Obviously, that's a challenge, and that'd be really fun to set up for a continuous running during like the November tour or something like that. But just the challenge of doing that seems like it'd be something interesting to do. So eventually, I might look into how I could. And of course, that's going to require other things as well, because when you run 2 trains simultaneously, you're going to have to not just control a turnout at each end of the reverse loop, but you're going to have to be able to probably stop one of the trains on a passing track, or slow them down or speed them up, things like that. So I'd have to maybe get some new knowledge from JMRI to do that. And then logic to run trains back and forth in the branch line. That'd be nice to have that going on kind of in the background where you don't have to manage it. So, but those are some ideas for future projects there. So the thing here being that with JMRI, there's no really anything you can think of and do with as far as layout logic and control, you could probably figure out a way to do it in JMRI without having to make any hardware modifications on your layout. So that's it.
David, I didn't want to interrupt on your change icons for your sensor button, the first item you had on your list. I drew a 1940s CTC panel on JMRI, and there is, I'm trying to remember where now because I've not been into that for a while, but there is a list of everything from little buttons to big buttons to humongous buttons. They even have some that look like they have the chrome bezel around the light, the sensor. There's even some European signals and stuff in there too. So just do some searching around, you'll find it, but there's the ones that you pop up are the little ones. I use those for the indicators on the track diagram. Then I use the bigger ones for the occupancy sensor. So they're in there. You just got to find them.
So they're in JMRI, not somewhere out in the internet, but you're talking in the JMRI library.
It's under Panel Pro, and I can't remember if it's under CTC tools or something like that. But there's all sorts of there's like 3 different sizes. You're using the smallest, what you had on your screen today.
Yeah. Okay. Good. Thanks. That's. I knew there was a whole bunch of icons in there, and I hadn't had a chance to really play with them. But that would be very
you
useful.
can take hours to look through all that stuff.
Yeah. Yeah.
I have a really excellent 3-part tutorial on how to get started with JMRI that will show you how to do that CTC panel and how to get to all those icons. So it's an excellent one. I can give the link. I'll give credit where credit's due. I didn't do it. I got it off the internet, but I can't remember where right now, but I'll give everybody the link.
Yes, thank you, because that's one I did do some searches when I was starting to do this, but it pretty much always took me to the manuals that the JMRI organization puts out. So, but no correction, I did find some YouTube videos on this stuff. And so that also helped from several years ago. Somebody had published a series of YouTube videos on signaling. So I looked through those, and that also helped get me going as well.
Did you see mine, David?
No, I didn't see yours. You have a YouTube video out there on this?
Yeah, I got a couple out there.
Oh, we'll have to do a search for those then. Okay, and that's the end of the presentation. Are there any other questions or comments?
Very good.
Yeah, very good.
Okay,
Are you in Houston, David? You talked about the November tours.
Yeah, Sugarland. I'm out in Sugarland.
Oh,
I've been on the tour last 2 years.
Okay, great.
Yeah.
Would
So I
love
try
to see your railroad.
Yeah, I usually align with the Katy group. So on the same day as they are. We'll see what happens this year with the tour. I was one of the ones who said I don't mind having people come over to take a look. So we'll see what we do if we're having a virtual tour or a physical tour.
From a Sandjack perspective, since I'm here, I can jump in real quick. Again, for those of you who have layouts, if you look at the Sandjack SD rail, there were some guidelines for how to create the videos for the virtual tours. It looks like, other than there's like 3 or 4 layouts of the 70 or so that Craig has in his library that will be open. So it looks like virtual is the way that we're going to end up going, and we'll probably have a weekend, David, where if those of you that want to be open, we'll publish that. But it would be nice to have everybody's layout at least documented. We've got a couple of people that have left us, and unfortunately, we're going to have to capture Jerry Ondex before Stephen decides to take it all back to Colorado. But we need to layouts. So if you don't mind, follow those instructions and send the videos to the link that's on there. It's a Dropbox. David Jansen will pick up the videos and edit them and post them back out on the Sandjack website.
Kelly, is that on the Sandjack website?
It is. The virtual layout tour will be published to the Sandjack website, or it may be a YouTube channel. I don't think David or Brian's actually decided how he's going to physically put it out there. But the rail is posted.
But I mean, to do those videos and stuff on how to do that, I'm not that savvy on that. That's on the Sandjack website, or Brian,
derail?
or-
derail is always posted to the Sanjak website, so yes,
Okay.
it's on page 19 of the derail.
This is the most recent derail that just came out, I think a couple days ago, a few days ago?
Yes, sir.
Yes, okay, I haven't read that one yet, so I'll take a look at that. Okay.
No, it's page 19 of that, and it is, it's a full page, came from 3 or 4 different sources. I put them together, and it's, turn the camera sideways, don't move too fast, those kinds of things. If you want to narrate on top of it, that's fine. David's also asked for a full page information that he can kind of post up on it. This is the layout it was built here. It's this railroad and this kind of thing. So, but it's all out there in that guideline.
Great, thank you.
Sure, Gordon.
Okay, David, how about unsharing your screen so that we can pop everybody up in bigger pictures?
Yep.
There we go. See? David's been using the new cameras.
Oh, yes.
Division 8 has, right? And he's been zooming around a little bit with it and everything. I just want to let everybody know that that was a gift from Sanjak Train Club. They gave us the monies to be able to buy this with. So these are available to anybody that wants to use them to do a layout. We have 2 cameras and a tripod. Both cameras have a zoom capability, and as you can see, back and forth, up and down control.
Really nice.
And one has a built-in mic, so they are pretty handy.
And what we haven't told Jim is that we're probably going to borrow those for the Sanjak meetings. So he just doesn't know that yet.
That's fine.
Jim, should I bring these cameras back to you or take them to somebody else then? Or
let's return them to me, because next month it looks like it's going to be Leslie's going to do. Leslie Eaton, she's a master model railroader. She wants to do a live presentation at the community center. Okay, and there's the potential that we'll be trying to Zoom that at the same time that she's doing it live at the community center. There's issues to be worked out, like who's going to attend to run the cameras, because of healthy reasons for my wife and myself, I can't attend. So if we can get somebody to volunteer to run the camera, we'll Zoom it at the same time. Okay. Just to let everybody kind of have a heads up that next month will be a live one, and we'll try to Zoom it.
So it would be interesting, Jim, to see how that works. Sanjak is considering the same in September, October, probably, to do what we call a hybrid meeting. So some people are online and some people are live. So I'd be interested to see how you do that. So I may be at the center that day too.
Okay, that's great. The more the merrier. Anybody have any more questions or any comments or input?
No, I want to thank David for putting this on today. A lot of great information.
thank you.
Did an excellent job, David. Thank you very much. All right, guys, I'm going to hit the end of the meeting here as I see everybody kind of filing out. I kind of like to be very close to the end. I don't like to be rude and cut people off. So
Yeah.
Take
All right.
care, all.
Okay. Goodbye, everybody.
Good.
Take care, everyone.
Good job, Dave.
Okay, thanks a lot.
See you Monday night, David.
All right.
And Bill. And Jeff.